Hello good people, I'm going to talk about orbital shapes. In the previous videos I kept saying how they are not circular. So what do they actually look like? Recall that atoms exist in three-dimensional space, and so the orbitals are also three-dimensional. This means that we need three axes, x, y and z. So let's start with an s orbital. What does it look like? Well, we are in luck here. The s orbital is spherical. So this fuzzy red sphere represents the s orbital. And it describes a volume where there is a 90% chance of finding an electron. At this stage you might say, well, what's the big difference? A circular orbit is kind of similar to a sphere. So why have I been talking so much about these orbits not being circular? That's because things get a bit more complicated once we start looking at the other orbitals. So let me get rid of the s orbital and bring in the three p orbitals. So now the shape is a little bit more complicated. The first one has these two lobes along the x-axis. So we call it the px orbital. The second one has the two lobes along the y-axis. So we call it the py orbital. And the third one has the lobes along the z-axis, so we call it pz. Just like with the spherical s orbital, these fuzzy lobes represent a volume where there is a 90% chance of finding an electron. So we went from a single spherical s orbital to these three dumbbell-shaped p orbitals. I wondered what the d orbitals have in store for us. Let me get rid of these and bring in the first three of the five d orbitals. So now we have these clover-shaped orbitals. The first one is in the xy plane, the second one is in the xz plane, and the third one is in the yz plane. Again, these fuzzy clovers represent volumes where there is a 90% chance of finding an electron. What about the other two d orbitals? Here they are. The fourth d orbital exists along the x and y axis and is designated as x squared minus y squared. The fifth and final d orbital looks quite different from the previous four. It has two lobes along the z-axis and then a donut shape in the xy plane. The designation for this orbital is dz squared. Hopefully at this stage you are getting an appreciation for the fact that the orbitals are not circular. They have rather distinct shapes. S orbitals are spherical, p orbitals are dumbbell-shaped, d orbitals are mostly clover-shaped, and f, well, the f orbitals are actually very complicated, so much so that they are beyond my limited artistic ability. And so I will not even try to draw them. The key message once again is that the orbitals are not circular. They exist in three-dimensional space and they have their own three-dimensional shapes. They start off relatively simple but quickly become rather complicated. That is all for now, and I will see you on the flip side.